Good morning or good afternoon, everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Josh from Business Review Webinars, and I will be your host. It is our pleasure to have Pilgrim International with us today, who will be presenting the webinar entitled, Why Do You Continue to Accept the Downside of Torque Tightening? Today's guest speakers are Ivan Kluka, Regional Account Manager, and Martin Kerrigan, Sales Manager. Before we begin, I'd like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. And in order to ask questions, you can send them in via the questions widget. Just type them into the box at the top right-hand corner of your screen and click submit. We will allocate some time at the end of the session to address any questions or thoughts that you may have had. And please use the yellow help widget if you require any assistance, and you can move, resize and maximize any of the windows in front of you to get a better view of the slides. But for now, please allow me to welcome Martin.
Thank you, Josh. Good day and welcome to our presentation, and thank you very much for your time. As Josh mentioned, today your presenters will be myself, Martin Kerrigan, and my colleague, Ivan Kluka. With us both having a mechanical engineering background and over 30 years of experience in most heavy engineering industries, we hope to have the knowledge of what most customers need, having both at some stage of our careers been the person using the solutions provided by others. Today, we will take you through various methods of bolt tightening and explain a little on how hydraulic tensioners play a big role in this. First, would like you to view a short video on who we are. Pilgrim has been at the forefront of critical bolting technology for over 60 years in every industry where this is a requirement, putting us at the forefront in the world of trouble-free connections. And through our inventive ideas and solutions, still remain the company of choice for bolting and tensioning systems, where we remove the uncertainty from critical joint fastening. Over these years, we've come up with thousands of solutions for many bolting applications, and we've categorized most of our product ranges into 5 simple, easy to visualize categories. Today, we shall concentrate on our hydraulic tensioning systems range, branded HYDROCAM. I shall now hand you over to my colleague Ivan, who will take you through the next few slides.
Thank you so much, Martin, and hello everybody. So, exactly what is tightening? Here are just 3 examples of the most common bolting arrangements used for bolted connections. There's a bolt and a nut, quite simple. A stud inserted into a blind threaded hole, plus a nut. And thirdly, a stud with nuts on both ends. We should also be aware that the forces on the joint can act in many ways. These include traction compression, traction and bending, sealed containment systems, shear forces, dynamic loading, and spontaneous loosening. all of these must be taken into consideration at the design stage to ensure the most effective method of tightening the bolts. Each bolt itself acts like a spring. Once stretched, it will always want to return to its original length. So, once we know what the load is required to secure the entire joint, we can introduce an applied load to each individual bolt. Tightening each nut under this load will result in an accurate total loading of the joint. But please note, the aim is to apply the same load to all of the bolts. Within the elastic range of the material, the more force you apply to the bolt, the more strain or elongation you obtain. As with a spring, when loading the bolt within its elastic properties, the bolt tries to come back to its original length, which translates to a clamping load. The natural behavior of a typical bolt material is that the longer the bolt, the more spring it is capable of. And conversely, a more compact bolt will be stiffer. As with the bolt, the structure itself also acts as a spring. When a compressive load is applied, the structure is going to compress. In addition, the thicker the material is, the more it compresses. Bolts are typically made from steel. Like most metals, steel is elastic, so long as the strain or elongation does not exceed the elastic limit or yield point beyond which permanent deformation occurs. Within the elastic limit, a metallic component such as a bolt follows Hooke's law. That is to say that the strain or elongation is proportional to the stress or load. Any tightening method must ensure that the stress in the bolt never exceeds the yield point, above which deformation is irreversible. Although bolt tightening can be effective from 50% of the yield point, the operator will typically target 70 to 80% of the yield point, because this is the optimal stress zone for tightening. So, let's put the two together. When a bolt and a structure are put together and tightened, a traction load, which is the blue arrow, is equal and opposite to the compression load, the green arrow. This slide shows what happens when an external load, which is the red arrow, is applied to the system. The more the external load grows, the more traction in the bolt is applied. It is going to act against the compression load of the bolt until the strain of the structure is zero. At this point, a leakage will appear, since the assembly is not compressed anymore. An external load could also increase the traction force beyond the yield point of the material, at which stage deformation will be irreversible. We'll now talk a little bit about alternative ways to tighten a bolted connection. And here is a short video to show just one method. Well, that's certainly one way to tighten a bolt. It is tight, isn't it? Well, maybe, maybe not. And in the world of critical bolted joints, We simply don't work in the world of maybes. As you can see from this particular graphic, the most common bolting issues arise from assembly errors. This doesn't necessarily mean the operator made an error. It could be that the method of bolt tightening simply wasn't the most optimum for that application, in which case, no matter how good the operator is, they could never achieve an accurate bolted joint. Here are some alternative ways of bolt tightening. There's hand torque wrenches, hydraulic torque wrenches, heat induction, and tensioning. Considering torque tightening, the most accurate method would be where there is absolutely no friction in the system to overcome, so that most of the torque is converted to tension load. But here's the reality. With torque tightening, there is always friction to overcome, both between the threads and the load-bearing surface and the face of the nut. In addition, a torque wrench will introduce torsion or twist in the bolt, which adds even further unknowns. Just so that we can understand the magnitude of these friction losses, here's an example where 520 Newton meters of torque is applied to a bolt. "180 Newton meters is used to overcome friction in those threads. A whole 273 is used overcoming friction between the nut face and the assembly. So only 67 Newton meters is eventually translated into an applied load in the bolt itself. So friction soaks up generally between 80 and 90% of the applied energy, leaving just 10 to 20% of the wrench's power to apply a load to the bolt. That is a lot of wasted effort. And that is just one of the reasons why there can be a high degree of uncertainty of the final bolt load when using a torque wrench, as your tightening method, along with the thread and the bearing surface condition, the type of lubricant used, if used at all, along with the calibrated accuracy of the wrench, which is generally plus minus 4% of the maximum output value, these introduce unknowns. Also, the effects of parasitic torsion cannot be dismissed, as the torsion within the bolt reduces tightness over time because it's trying to loosen the bolt during normal service. This problem can be further exacerbated if also subjected to vibrational forces. But of course, there are advantages and disadvantages to all tightening methods. And what we want is the most effective and accurate method for your application, and a method that can cover all your applications with the greatest accuracy and the least chance of operator error and the highest amount of safety when applying this method. Which leads me on to the next method of bolt tightening, through the use of hydraulic tensioners. A standard hydraulic tensioner is made up of several parts to give a complete full assembly. There's the brace, the hydraulic body, and the skirt. Then accessories such as sockets and Tommy bars are used to aid bolt assembly. In the following video, we will show you how these parts come together to easily apply a load to your bolt. Now, let's see how the tensioner applies a high pressure to the bolt. Firstly, we know that the yield point should not be exceeded. Secondly, the residual load should be within 80% of its yield point. This is calculated at the design stage to ensure a controlled and accurate load is applied to all of the bolts within their elastic limits. The socket is placed over the nut, and the brace or puller is then screwed onto the bolt. The tensioner is pressurized, which stretches the bolt to a known hydraulic load. The operator screws down the nut, and the pressure is released, leaving a known residual load within the bolt, which is a function of the clamp length to diameter ratio. The tensioner in the socket can now be removed. The end result is accurate tightening, which will be repeatable every time, and the elimination of uncertainty. For even greater accuracy, we would highly recommend the bolts be tightened homogeneously. This means tightening several bolts simultaneously. Homogeneous tightening is particularly important when it is critical to ensure that an even load across the whole application to avoid any distortion by tightening a single bolt at a time. I think we've all seen this effect when changing a car wheel. Tightening one bolt can affect the tightness of all the other bolts around it. As each set of bolts are tightened, the surrounding bolts may lose load. And to eliminate this, we would recommend that 2 or more passes are made around the bolts. This is further illustrated in this slide. This is tightening up bolt number 1. We then start to tighten bolt number 2. And you can see that the load in bolt number 1 starts to reduce. The advantages of hydraulic tensioning are absolutely vast. There's a more accurate, repeatable, and controlled loading. It's simple, quick to use, with no damage to any surfaces or components. Simultaneous tightening of several bolts can be used to save time, and we can also incorporate a fully automated system if required. Thank you, and I'll hand you back to Martin.
Thank you, Ivan. I will now take you through the last few slides, concentrating mainly on our HYDROCAM range of tensioners and where they've been used in some applications. Our HYDROCAM range can be split into 3 simple categories, starting with our standard range of tensioners, covering most standard thread sizes and coming both the single and double stacked to a greater load in a smaller area. In the second section, as Pilgrim both design and manufacture these units in-house, they can be easily adapted to suit your application by redesigning the skirt and the brace where space may be tight. And in the third section, our bespoke custom design units with multiple tensioners incorporated into a section ring for a quicker and easier installation to the application, giving a 100% coverage. They also come with options like automatic nut turn down, automatic piston return systems, and overstroke limiters to stop you overstroking the piston. As most of our tensioners use a brace to attach to the bolts, You can even have multiple brace thread sizes that utilize the same cylinder and skirt. And these thread sizes come in both metric and imperial, ranging from as small as M8 all the way up to M160 and even greater upon application. A huge range of thread sizes. It saves cost and stock levels. And as you'll see in this graphic, the HTS2 and the HTHR are double stacked units. These allow for a greater load over a smaller area and are incredibly popular in the wind farm industry, where space is generally very tight. We can adapt or design any tensioner to suit your needs. Micro tensioners that start as low as M5. Multi-tensioner rings incorporating many tensioners into a single unit. Units made from different materials for maybe weight reductions, where maneuverability is not so easy, or you have a harsh environment. We can also use water as the medium to create the load in the cylinder. For applications, leakage of oil could impact the environment. Again, very popular in the subsea applications. It's a not so common medium, and it's also quite unique to HYDROCAM. And of course, we're constantly updating our designs and incorporating new aspects to further reduce time and energy required to complete your bolting requirements. As you'll see in the video playing in the top right, our quick connect tensioner saves even more time by allowing the operator to simply drop the whole unit onto the bolt. It secures itself to the bolt with no screwing down of the brace required. Again, very popular in the subsea range, saving time and energy from the diver, giving a very quick return on investment. And in the below section, the aforementioned multi-tensioner rings, allowing the installation of multiple tensioners, creating a perfectly homogeneous fastening of multiple bolts simultaneously. And of course, we provide all the peripherals that you may require. Our range of pumps come in hand-operated, air-operated, and electrical. We can supply all the hoses and fittings, and a range of connector blocks to couple multiple tensioners from one single pump unit. So, as you can see, from our standard range through to our bespoke units, we have a solution for every application within every industry that requires controlled and accurate bolting. In this last section, I will take you through just a small selection of applications that we've provided solutions for. Hopefully, one or more of these may even be familiar to yourself. The first application, we supplied our standard HTA tensioners. They fastened several bolts holding together a large press in a rolling mill. The result in this was a huge reduction of downtime when maintaining the presses. But they also had zero damage to the bolts or the surfaces. This increased the production time of the press, again, giving a very quick return on investment. This particular application was on the Öresund Bridge, which connects Sweden to Denmark. It's the largest road and rail bridge in Europe. What they required was a tensioning of 20 studs simultaneously on the cable anchor system. Not only did they need them to be tensioned together, they also needed it to be perfectly in alignment. So by the use of our spherical seating system, we were able to make sure that all the units self-aligned as the load was being introduced, keeping everything perfectly straight. Again, greatly reduced downtime, kept the bridge open when it was needed. This particular application. This is a ropeway transport system, and it actually required an adaptation of our standard HTCR range. The bolts were to secure the foundations, and as you can see from the picture, they was very tight. So we adapted the skirt and the body to fit into the geometry of the foundation. And again, we used a spherical seating to ensure that no bending was incorporated while it's inducing the load, as the base wasn't perfectly flat. And again, reduced downtime, but also the operators found this a much more simple process. This application is probably our most common and also our most successful, securing a slewing bearing. This bearing was on a catenary anchor leg mooring system where the bearing itself was within a turntable. It's a very critical application, as this is where offshore vessels are moored whilst in operation. So by using 4 of our HTCR units, they were able to quickly replace the bearing and return to operation in record time. But also, by tightening 4 tensioners simultaneously at 90-degree intervals, it ensured that there was no distortion of the bearing itself whilst loading the bolts. And this helped ensure its performance in operation, but also to obtain its maximum working life. This is particularly good because we were very privileged to be chosen to be involved in the construction of the Deep Blue. The Deep Blue is the largest purpose-built pipeline and subsea construction vessel in the world. But most of its structures were supersized. For this application, they required the tensioning of 6 large bolts to hold down their bearing housing, which incidentally held 2 of the largest bearings ever made. 3 bolts were at M64 and 3 bolts at M180. Sorry, M80, not 180. There was a large amount of force required to secure the housing of these bolts. So after a design review, our standard HTA tensioners were selected. So we actually already had a perfect solution, designed and ready to go for a quick turnaround. This allowed the customer to continue with the construction, no delays, and no delays to their delivery schedule. The final solution, but by no means the least, a real favourite of mine as well. This is a nuclear submarine built in the UK. They required the tensioning of several Inconel studs, which incidentally were also supplied by Pilgrim. They previously used another company's tensioners to fasten these studs, but upon removal they found damage to the seating surface. This was probably due to maybe an incorrect selection. But then this required remachining, which was both time-consuming and expensive. By using HYDROCAM and following a full design review, special bespoke tensioners were designed. This eliminated the problem for future maintenance schedules and gave a more predictable scheduled time frame with no surprises and a really huge reduction cost and time. Well, that's where we'll leave it for now. I will hand you back to Josh, who I think will run through some of the questions and hopefully we can provide you some answers. So I thank you very much for your time, and I'll hand back to Josh.
Thank you very much, Martin. Fantastic presentation there. Just a reminder for the audience, in order to ask questions, you can send them in via the questions widget. Just type them into the box at the top right-hand corner of your screen and click submit. But in the meantime, we have had some come in. This first one here is asking, how do I ensure my operators do not exceed the stroke limits of the piston?
That's a good question. Yeah, I mean, we have a part which is called a stroke limiter. So we can incorporate this into the tensioner itself. And basically, as the stroke is reached, it opens up a port internally and allows the oil to flow through back to the pump. So this basically means that there is no way you can go beyond the recommended stroke for that particular unit. So I hope that's helped.
Yeah, that's brilliant. Thank you very much. Another one here is asking, would it be possible for you to recommend the best sequencing when tightening the bolts if we were to use a 25% or less coverage?
Thinking about the question, good one. That wouldn't be a problem. What we would need to do is look at the particular application. All applications are different, unfortunately. There's no genuine quick answer to that one. So we'd look at the application. We'd need to know information about the surrounding structures because that also can have an impact. And we would certainly advise the best and optimum sequence for that particular application. So in answer to your question, yes.
Brilliant. Thank you very much, Ivan. There's another one here asking, do your tensioners come with 2 ports to link them together for tensioning of multiple units?
Yes, we can certainly incorporate 2 ports. I think what you're alluding at there is a method of linking multiple tensioners together called the daisy chain effect, whereas you have a hose from the pump coming to the first tensioner, and from the first tensioner, a smaller hose links to the second, and this goes on like a daisy all the way around until a blank port at the end. So yes, if that is your preferred method of introducing the load into multiple tensioners simultaneously, we will certainly be able to do that for you, no problem, and supply all the extra hoses, etc. And also, of course, you can also do this via a connector block. So you could have a similar effect, one pipe coming into a connector block, which then has hoses running from it to connect to each tensioner if it only had 1 port. So yeah, by all means, if that's your preferred method, upon application, you just mention this and we can certainly incorporate that into the design.
Brilliant. Thank you very much. Just a reminder to the audience, and you can still submit the questions via the Q&A widget. It'll be in the top right-hand corner of your screen, or it'll be a small purple box at the bottom. Don't forget, you can still ask it throughout this whole session, and we'll answer as many as we can. We've got another one here asking how much bolt thread is needed above the nut to fit the tensioner on.
A simple rule of thumb, if you want to call it that, we would recommend a minimum of 0.8 times the thread diameter of the thread above the nut to allow the brace or puller to be safely attached. Hopefully that answers the question.
Yep, brilliant. Thank you very much. Here's another one. Can I use a tensioner to break out a bolt I already have in the situation?
Yeah, well, I suppose the simple question is yes, but there would actually we need to know a few things before we could select the tensioner. So what we would have to do is we would have to know what materials you've got and the geometry. And then from that, we can work out the calculations to make sure that the unit supplied is within its safe limits and we won't actually cause any damage to the bolts, so we keep it within its yield limit. So, yeah, a few questions we'd have to ask first. And from there, we would do a quick design review and a few calculations. We'd then be able to offer you a tensioner and give you a recommended pressure to apply to it, which should be enough to separate the nut from the surface space and then simply screw off.
Okay, brilliant. Right, yeah, by the sound of it, that is all we've got time for then. If we haven't got around to answering your question, don't worry. The guys will be able to contact you at a later date. So that just leaves me to thank Ivan and Martin for what's been a great presentation, and to Pilgrim International for sponsoring this session. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.pilgriminternational.com. business-review-webinars.com. And we look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group, Business Review Webinars. But again, thank you for joining us, and I hope you all have a fantastic day.
Thank you very much, everybody.